Okay, Frosty, sit. Sit. That's a good one. Frosty, shake. Good. It's a little thing for you. That's good. Okay, Frosty. Today we're going to talk about an arithmetic series. First, I want to make sure you have enough to eat. There's another moment. Okay. Now, an arithmetic series is a sequence of numbers. The simplest one would be numbers like this. 1, 2, 3, 4, 5. That's an arithmetic series with 5 numbers in it. Those numbers are spaced, or the difference between the numbers is 1. Here's another arithmetic series. 2, 4, 6, 8, 10. That's an arithmetic series that had 5 numbers in it. The spacing between the numbers was 2. Frosty, can you sit again? You paying attention? There you go. How are you doing today? Okay. Frosty, pay attention now. We're going to go over on the blackboard. In this case, we're going to use the blackboard today to learn about arithmetic series. And I have a cold today, so my voice is going to be a little congested. Okay, now the arithmetic series that I just showed Frosty was this one. 1, 2, 3, 4, 5. And we also talked about another one. 2, 4, 6, 8, and 10. An arithmetic series is just a list of numbers. And the thing about the numbers is the difference between any two adjacent numbers is the same in the series. So this is a series where the difference is 2. Here's a series where the difference is 1. Both of these series have 5, but the number could be any number you want. And you could start wherever you want on a series. The series could go up, it could go down. Okay? Now, one of the things that you learn to do with an arithmetic series is how to add up. It's called summing an arithmetic series. So I'm going to give you an example of a problem. I'm going to take the numbers 1, 2, all the way up to 100. That's an arithmetic series with 100 terms. And the problem is going to be how to add up all of the numbers in the arithmetic series. Now this happens to be a problem that might have been, excuse me, part of a very famous story in mathematics. It has to do with a very famous mathematician named Carl Gauss. When Gauss was 9 years old, he was in elementary school. Those were in the days when they used a slate or a blackboard or a chalkboard. Each student would have a little chalkboard, and they would write on their problems, their arithmetic problems, with chalk. Gauss was only 9 years old, but he was in a class with other kids that were 15 years old because he was advanced, because he was very good at arithmetic. And one day, the teacher, whose name was Büttner, and these were the days when the teacher would carry a stick, and he would hit the student if he needed to. And so in those days, students usually didn't do much back talk. Now, Büttner gave a problem to all the students. It was a problem of summing an arithmetic series. And in those days, in Büttner's classroom, whenever a student was finished with a problem, they would take their slate and they would turn it upside down on a table in the middle of the room. And then the second person to finish the problem would put their slate on top of that person's. And then they would go until everyone finished. And then when they would, at the end, they would turn them all over. So the person who put the answer down first, they would be at the top of the pile, and then they would look at their answer, and then they would see who got it right. Now, in this arithmetic series, Gauss got the answer almost instantly. We don't know, but he got it pretty quick. And then he was the first one to put his slate down. Now, Putner gave the students 1 hour to sum this arithmetic series, so there must have been a lot of numbers in it. That's why I picked this one, 1 to 100. If you had to add the numbers between 1 and 100, how long do you think that could take? Yeah, that might take an hour. And you'd have to do it just on a little blackboard, a little slate chalkboard that you had on your table. Well, that's gonna take a long time. Now, Gauss did it very quickly. And so Gauss must have had a trick. He couldn't have added up all those numbers. Well, I don't know. I don't think so. If you try adding 1 plus 2, that's 3. 3 plus 3, that's 6. 6 plus 4 is 10. Plus 5 is 15. Yeah, I suppose you could do that, but you might make a mistake along the way. Now, this is the way. Now, Gauss, when he was older, he always used to tell that story over and over and over again. Because that was one of the big highlights of his life. Everybody has something like that where they'll remember a certain story where they did something that was really good. Gauss, that was one of his highlights. It was only when he was 9 years old, even though he went on to solve, well, he was like possibly the best mathematician of all time. But that was the story he liked the best. Okay, this is how a lot of people today think he might have done it. He might have done it this way. It's really a trick, and once I show it to you, then everybody knows it, and then it's not hard anymore. What you do is you write the sequence in reverse order. All the way to 1. Then what you do is, you notice that when you write them in reverse order, that if you add the two sequences, each number in the sequence adds to 101. Okay? Now, adding up all of these is easy. That's just 100 times 101. That's just equal 101, and then you just add 2 zeros. It's 10,100. Now, this is the sum of these two series. So the actual answer is going to be half of this. So to get the actual answer, which I'll just call answer, that's going to equal half of this. You have to divide it by 2. You take all of these numbers, you add them up, which is just multiplied by 100, then you divide it by 2, and that'll give you the sum of the original arithmetic series. Which in this case is 5,050. It's a lot quicker, and it's more accurate because you're not going to make a mistake as easily. So that's the trick. That's the trick. Is you just write it in reverse order, and then you can generalize this. You'll see that the actual answer here, the way to get to the actual answer is you take the first term in the series, the last term in the series, you add them together. You multiply that by the number of terms in the series. So when you add them together, you get 101. The number of terms in the series is 100. You multiply them and you divide it by 2. So to get a general formula, let's write it like this. Let's say the series was like this. A0, A1, A to the n minus 1. These are subscripts, but I'm just saying that I'm going to start the first one and call it 0. There's going to be a total number of n. If I want to get the summation, according to what we just talked about, I take the first one, I add it to the last one. I multiply by the total number, which is n, and I divide by 2. See, I just put down the formula. But you can imagine all of the other little steps, like writing down the first one in reverse order, writing it in reverse order, adding them all up, each term, now it's going to give you the exact same answer of the first one plus the last one. There's going to be n of them. So you add all those up by multiplying by n. Then you have to divide by 2 because you had added the series twice. And this is a very famous formula. for the sum of an arithmetic series. By the way, this formula was not invented by Gauss when he was 9 years old. This formula was actually known to the Greeks and hundreds of years before Christ. It's just that people think that nobody told Gauss about it before he went to that class, and that he might have thought it up, as it were, for the first time. But, you know, even back in the days of the Greeks, somebody thought it up for the first time. So it's not a complicated formula. And you want to do is in your mind, just remember, not to memorize the formula, but to remember that you want to add the first term in the series, the last term in the series. Multiply by the number of terms in the series and divide it by 2. And if you can remember how we did this, that's a way of remembering that formula. And you might have some problems where you have to do that on your homework. So that's something you want to remember. Okay, that's all.